The quotient rule of differentiation. How to compute the quotient rule of differentiation? And when can the quotient rule be used? The quotient rule can be used when a function u is dividing another function v. So if we have something like this, provided u and v are differentiable, then we can call it the quotient rule of differentiation. A formula is being used to compute equations on quotient rule. And that formula states the y all over the x. Please, for more on this, you need to subscribe to this channel. The y all over the x is equal to v du all over the x minus u dv all over the x all over v squared. So this is the formula used in computing equations on quotient rule of differentiation. Let's take a question for we to better understand how to use this formula. Example. Differentiate with respect to x given 1. Y is equal to x squared all over x plus 2. First question. Number 2, y is equal to 2x minus 1 all over 3x plus 2. So we have two equations here. If you see this equation, a function is dividing another function. So we use the quotient rule of differentiation. Here, a function is dividing another function. We also use the quotient rule of differentiation. Solution. Solution 1. We have that y is equal to x squared all over x plus 2. We take this as our u and we take this as our v. So we use the formula y all over dx is equal to v du all over dx minus u dv all over dx all over v squared. So we just substitute. This is our v. The y all over dx is equal to our v. This is v. We say x plus 2 x plus 2. We also have the u all over the x. The u all over the x, we have to differentiate this function. We differentiate this with respect to x, and if we differentiate this, we get 2x minus u. We bring down u, x squared, and differentiate this function. If we differentiate this function, we get just 1 all over v x plus 2 all squared. So the next thing to do is just to open our brackets. This multiplied by this, we have 2x squared plus this multiplied by this, 4x minus x squared all over x plus 2 raised to the power of 2. So if this goes into this, we'll have x squared plus 4x all over x plus 2 raised to the power of 2. So on the y, the x is equal to this as our answer. We take the number 2 question. The number 2 question, number 2, says y is equal to 2x minus 1 all over 3x plus 2. You need to subscribe to this channel for more on differentiation. We take this as our u, and we'll take this as our v. We'll also rewrite the formula, the y all over the x is equal to v, the u all over the x minus u, the v all over the x all over v squared. So we substitute the values for u and v into this and differentiate where possible. So we use these parts. All right. So the y all over the x is equal to v. This is our v. 3x plus 2. We bring it down. 3x plus 2. Multiplied by the u all over the x. The u all over the x. We differentiate this whole function with respect to x. So we have, if we differentiate this with respect to x, we have multiplied by 2 minus u. We bring down u, which is 2x minus 1. Also, we differentiate the v all over the x. The v all over the x. We differentiate this with respect to x. So if we differentiate this with respect to x, we just have 3 here. So we have 3. All over v. This is our v. We now have 3x plus 2 all squared. So it's equal to this multiplied by this. We have 6x plus 4 minus, here we have 6x minus 3 all over 3x plus 2 raised to the power of 2. The y all over the x. Also, the y all over the x is equal to, we open the bracket, 6x plus 4 minus 6x plus 3 all over 3x plus 2 raised to the power of 2. So as we can see, this will cancel this. Therefore, the y all over the x is equal to 4 plus 3 is 7 all over 3x plus 2 all squared and raised to the power of 2. So this becomes our final answer for the number 2 question. This is how we can compute the quotient rule of differentiation. For more on this topic, subscribe to the channel.